Good morning. So we are continuing with the series of solving the basic questions on the given chapters, and today our chapter will be Introduction to Graph. Let's see the first problem. The following graph shows the temperature of a patient in a hospital recorded every hour. What was the temperature at 1 p.m.? What was the temperature at when was the temperature 38.5? The patient's temperature. There are 5 questions. Let's see one by one. What is the temperature at 1 p.m.? 1 p.m. the temperature is 36.5. The answer is 36.5. This is how we can read the graph by just putting the appropriate axis or appropriate scales. When was the patient's temperature 38.5? When was it 38.5? The temperature 38.5 was at 12 noon. The patient's temperature was the same 2 times during the given period. What are these 2 times? The same temperature. The same temperature is this. The temperature was 36.5 and it was at 1 p.m. and 2 p.m. 36.5 was the temperature. Because the temperature, it was between 1 p.m. and 2 p.m. Was question number C का answer is 1 p.m. and 2 p.m. Question number answer D. What was the temperature at 1:30 p.m.? How did you arrive at your answer? Now, the temperature at 1:30 is not recorded. There is no record of that. There is no dot here, which means that the temperature was never taken at 1:30 p.m. So how can I tell what is the temperature at 1:30 p.m.? I am only guessing, and my guesswork is based on some statistical data. What is that statistical data? The temperature at 1 and the temperature at 2. Matlab 1:30, the left hand reading of 1:30, the previous reading and the next reading of 1:30. Both readings are equal and those readings are 36.5. So I am entitled to assume, or I can assume with fair accuracy, that the temperature of the patient between 1 p.m. to 2 p.m. remains stable and the temperature is 36.5. Again, this is an assumption. Can it happen that the temperature here was 36.5, the temperature at 2 p.m. was also 36.5, but between 1 p.m. and 2 p.m. the temperature shot up and then came back again? It is possible. In some cases it happens. Certain patients have this, the tendency or the behavior, or certain cases are seen where the body temperature rises for a very brief amount of time, and after some medication it comes down again normal. Is it like that? We don't have the data to show that. So we'll just assume that it was uniform. So the answer is because the temperature is assumably constant. We are assuming that it is constant between 1 p.m. and 2 p.m. During which period the patient's temperature showed an upward trend. The temperature is increasing from 9 to 10 and then 10 to 11 as well. From 11 o'clock onwards, the temperature is dropping and it is coming constant here up to 2 p.m. Then 2 to 3, again the temperature is increasing. So the temperature is increasing from 9 to 10. This answer needs some correction. 9 to 10, 10 to 11, and then 2 to 3. That will be the answer to question number E. This is how we can interpret from the given graph. The graph is given, we are interpreting. But can we also draw the graph? Let's see. Use the table below to draw the linear graph. The number of days a hillside city received snow in different years. So there is a hillside city like Manali, like Leh, like Ladakh. There is a city, there is a town which is right on the hillside. And there is a snowfall. Every year for some days the snowfall takes place. Not every time. It is not like in the peaks of the Himalayan ranges where the snow is evident 365 days a year, or it is not like for 8 months there will be snow. It's not like that. But the snowfall will take place during winter. So how many days? In 2003, 8 days. 2004, 10 days. 2005 suddenly it dropped. Maybe the weather changes or whatever. 2006 12 days. You can draw this as graph. 3, 6, 9, 12, 15. You see that you have this is called a scale. 1 centimeter is 3 units on y-axis. 0, then 3, then 6, then 9, then 12, then 15. So I am choosing 1 centimeter equal to 3 degrees Celsius or 3 days, not degrees Celsius. Y-axis is days, the number of days. And on x-axis, this is far greater than 1 centimeter. I choose, let's say, 4 centimeter. After 4 centimeter, I made this line. So 4 centimeter is 1 year. So from here to here, 4 centimeter, 4 centimeter, 4 centimeter, 4 centimeter, and so on. We can also do it this way. Sometimes the graph, to be more precise, to be more accurate, people also show this line is not shown continuous, but it is shown like resistance in electricity. It is shown like this. This symbol means that the graph is starting from 2003 on this side. This is 0, but between 0 and 2003, a lot of space was there, but there was no point to be plotted. So we are not showing that. Like in this case, your timeline could start, the year could start from 0th year or 1st year of the timeline whenever we started to measure the Gregorian calendar. But it is pointless. Our reading starts from 2003. Why write anything before that? So this symbol shows our reading is starting from 2003. There are a lot of values in between that, but there is no data available, so we are not showing it. So this symbol shows that there is a lot of space here. So it basically saying that if this is 2004 and this is 2003, then somebody will say, sir, this is 2002, but we are having y-axis here. इसका मतलब यहाँ पे x का वैल्यू तो 0 आएगा, मतलब टाइम 0 आएगा, तो इसलिए ये सिंबल बनाया है. 2003 पे 6 और 9 के बीच में यहाँ पे 8 आप चेक कर सकते हैं, ये एग्जैक्ट मिडिल में नहीं है, ऊपर आया हुआ है. 2/3 ऐसा डिस्टेंस ऊपर कवर किया है. फिर यहाँ पे आएगा 10, 5 and 12, and you just draw the line joining these points. This is called a line graph. We can draw a graph like that. We could choose a better scale where ये 3, 6 में यहाँ पे 8 showing 8 was a difficult problem, showing 10 was a difficult problem, showing 5 was a difficult problem, only 12 was shown very easily. So you could choose some other scale here, like 1 centimeter is equal to, rather than 3 days, you could take 1 centimeter is equal to 2 days, and showing this would be very easy. I had to take this scale because the space was limited. I wanted to show this problem on the slide, and then the space available for the graph was very small. So I had to squeeze in. So I choose this kind of scale. Next problem. Population in thousands of men and women in a village is shown in different years. So in 2003 there are 12,000 men and 11,300 women. 12.5 thousand men in 2004, 11.9 thousand women in 2004, and so on. Let's show this. So these are the x-axis, y-axis. Again you will see there has to be this hatching line here. Not hatching line actually, it's like when this is drawn, we know that there is a lot of data, but we are not showing it because there is no value here. A lot of things could have been. So from 2003, 12,000 is the number of men, 11, 11.5, 12, 12.5, 13, 13.5, 12 here. This black line shows the graph for men, population of men. The red line shows the population for women. So ये यहाँ पे women. Draw, just plot the points and join the points accordingly. For men, it is best that you don't plot all the points together. Only plot for men first, make that line. Then plot it for women and then make that line. Because sometimes what happens is while joining the dots, we forget that if the next dot is we are joining is of man or woman, and the graph becomes haywire. So we don't want to create clumsiness, we don't want to create confusion. एक बार एक कैटेगरी का ग्राफ बना लो, पूरा बना लो, फिर दूसरा स्टार्ट करना, फिर दूसरे के पॉइंट. Yeah, the same thing. A courier person cycles from one town to the neighboring town to deliver a parcel to a merchant. His distance from the town at different times is shown by the following graph. What is the scale taken on time axis? This is time axis. See the scale. 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter. 4 centimeter is equal to 1 hour. 4 centimeter, 1, 2, 3, 4. Next 4 centimeter is equal to 1 hour. Yeah. 4 centimeter is 1 hour. So the scale taken is 1 centimeter. Scale is normally written for 1 centimeter. You can write scale on time axis. We could write 4 centimeter is equal to 1 hour. Or you can say 1 centimeter is equal to 1 by 4 hour. Both mean the same, you know, right? You could write it this way or you could write it that way. The next one, how much time did the person take for travel? So he started at 8 and he, let's say, delivered at 11:30. So he's taken 5 hours and 30 minutes. How far is the place from the merchant? How far is the place of the merchant from the town? From the town, the distance traveled to go to the merchant is 22 kilometers. So the distance is 22 kilometers. Did the person stop on his way? Explain. यहाँ पे देखो ये for in between this time 10 to 10:30, the distance has not changed, so it stopped. He must have been having some chai, must have been having some breakfast. It is okay. He stopped. Part of the game, part of the work. During which period did he ride fastest? Fastest मतलब maximum growth on distance in minimum growth on time. That is when the motion is fast. So you have to go fastest. तो यहाँ से यहाँ पे अब आप चेक करो यहाँ पे 1 घंटे में this man is going 10 kilometers. Next 1 hour the man has gone 6 kilometers, and here as well the man is going 6 kilometers in this hour. So this is the first hour. Maybe the man was going cycling, so initially the enthusiasm was pretty on the high, pretty much on the high. So he rode 10 kilometers in 1 hour. Next, scale 3.5 hours. 3.5 hours. Did I make it right? Hello. 11:30 to 8. Yeah, 3.5. My mistake. It is 11:30. Not 1:30, it is 11:30 to and 8. Yeah, 3.5 hours it took. 22 kilometers is the total distance it traveled. Yes, the graph shows horizontal line between 10:30 and 10:30. No, it shows from 10 to 10:30. 10 to 10:30, yeah. So the person stopped for half an hour. From 8 a.m. to 9 a.m. the person has covered 10 kilometers. That is the highest speed. Next problem. Draw the graph for the following tables of values with suitable scales on axis. Cost of apples. We are drawing this graph now. 1 apple, 2 apple, 3 apple, 4 apple, 5 apple. 5 rupees, 10 rupees. It's a completely directly proportional kind of graph. We have this chapter as well. That's proportion, direct and inverse proportion. So it is like direct. One apple costs 5 rupees, 2 apple costs 10, 350, 420, 525. Perfectly proportional. It will be a perfect straight line. See this. On the x-axis I am showing 1, 2, 3, 4, 5. The scale that I chose 2 centimeter is 1 apple on x-axis. On y-axis 2 centimeter is 5 rupees. This is scale, the scale is chosen to draw this graph. But again, if you see that on your graph paper, there will be lot of distance on x-axis. I am only covering these 2 centimeters, 4 centimeters, 6 centimeter, 8 centimeter, 10 centimeter, 12 centimeter, and if we go beyond this, 14 centimeter I am covering. Normally on a graph paper, there are 18 centimeters available on x-axis. So you could have adjusted the scale. I prefer not to adjust the scale because I don't like to get into fractional values. On y-axis I could have adjusted the scale, but the available space here was less on this chart, on this paper, on this page. But otherwise, if I have a complete graph, then on a graph paper the line, the y-axis can have much more. This is 2 centimeter, 4, 6, 8, 10. 12 and नीचे एक 15 centimeter. The graph will be 22 centimeter at least in height. So we could have adjusted scale, but I like this scale better actually. If anything, I could have done कि 3 centimeter is equal to 5 rupees on y-axis. That is the scale I would have taken otherwise. But this scale is good. This is good. And if you see the graph 1, 5, the point is plotted. 210, 315. 420, 525, the points are plotted. Just draw the graph. Done. This one, 6 a.m. 40 kilometer distance. Distance traveled by a car. Maybe the car started at 5 a.m. Maybe. I'm just assuming. I'm just guessing. So it started at 5 a.m. let's say. And at 6 a.m. it had already covered 40 kilometers. 7 a.m. it had covered 80 kilometers. So in this 1 hour it has covered from 40 to 81 the 40 kilometers. That's why I'm assuming it must have started at 5 a.m. So it covered 40 kilometers till 6, 80 kilometers till 7, 120 till 8 and 160 till 9. 6, 7, 8, 9. Again 2 centimeter is 1 hour duration. 6 a.m., 7 a.m., 8 a.m., 9 a.m. Graph this could have been 3 centimeters is equal to 1 hour. It would have also been possible. It would have fit. I have preferred doing this. You can change the scale, there is no problem. On this scale as well, 2 centimeters is 40. 0, 40, 80, 120, 160. But you could have taken 3 centimeters equal to 40 as well. It is possible. Just plot the points, draw the graph, that's it. Now the question about which scale to choose and which scale should you not choose, we'll just devote our attention to that problem. I am only solving this problem, only this problem again. This has already been solved. Now I'll choose one more scale and show you what happens if the scale is chosen different. On y-axis, I have chosen a different scale. Yeah. On y-axis, I am saying 1 centimeter is equal to 40 now. Here it was 2 centimeter equal to 40. So if 1 centimeter is equal to 40, this will be 0, 40, 80, 120, 160. And the graph looks like this. The line is slightly here and there, but don't mind that. You can draw the better graph. There is no change on the scale on x-axis, but the scale on y-axis has changed, and the graph has shrunk. If you want your graph to completely spread over the graph paper, or at least half of the graph paper, you got to choose the scale accordingly. The scale should be at such that not like 1 centimeter is 40. You can take 2 centimeters 40. You can also take 3 centimeters 40. Some students take 4 centimeters 40. They take 1 centimeter equal to 10, and it goes from 0 to 16 centimeter, and it works. The graph shows beautifully spread out graph across the entire graph paper. But what happens when you choose the scale differently? The graph looks slightly different. Although it is straight line graph in both the cases, but it looks shrunk. This looks completely good spread out. That's all. I hope you understand this. I hope you understood this chapter. The chapter is very simple. Practice, just solve these basic problems, and that will be good enough. Thank you.